In today's video, you're going to learn about biogeochemical cycles. While you're watching and listening today, you should try to identify this idea of what is conservation of matter. Simply the idea that matter, like energy, is neither created nor destroyed, and it just cycles from one thing to another. So you won't have exact numbers on it, but you should be able to see the connection. Secondly, during the video, you should try to identify how the nutrient exchange is important in sustaining life. So notice how the different living organisms in the video are really using the nutrients as part of the cycle. In this segment, we're going to talk about the carbon cycle. So where does a lot of our carbon originally come from? Well, if we look in this image here, what you don't see is to the side, this is actually part of an old volcano. And a lot of the original carbon that got into our atmosphere, and today even, came out of things like volcanoes. They help to cycle carbon out of the earth. So in our atmosphere, we have a lot of carbon dioxide. And that carbon dioxide goes back into the earth or back into living things in a few different ways. One, some of the carbon dioxide in the atmosphere can get dissolved into water, specifically the ocean. The ocean takes up tons of carbon all the time, a lot of the carbon that's in the atmosphere. Another place that this carbon dioxide can go to is directly into living plants. So the plants take in that carbon dioxide as well as a lot of the plants that are in the ocean. So let's just draw a few little circles here, and let's say these are plants in the ocean that have taken in some of the carbon dioxide that was dissolved into the water. So the carbon dioxide, you can see, is already starting to flow. Now what happens is these green plants, which have carbon in them now, can be ingested by herbivores. So that tortoise over there, or possibly if I have some kind of animal in the ocean that is going to ingest this carbon from the plants. So these herbivores are going to take in some of the carbon, or possibly some of this carbon could go into something like a shellfish, where we might have calcium carbonate being formed as part of their shell. Now, we're looking at how carbon is being taken in from the atmosphere. And one of the things that we can assume is that these plants could die, this animal could die, this animal could die. And all of these things, let's give our ocean a little bit of completeness here. All these things could eventually go and settle to the bottom of the ocean. So all of these dead organisms are going to break down into smaller parts. They're going to settle down in the bottom of the ocean, and all of that sediment is going to build up over long, long periods of time. So even here, the sediment is going to get absorbed into the earth or possibly go into the ocean. And these sediments are building up over a long period of time. And one of the things that can happen over millions and millions of years, they can get under so much heat and pressure under layers and layers and layers of the earth that we can eventually form a fossil fuel, which many of you are familiar with. This fossil fuel is basically the trapped carbon from all of that plant matter or animal matter that's been built up over long, long periods of time. From there, we start to find ways that the carbon can be released back into the atmosphere as part of this nutrient cycle. So one of the ways the carbon can be released is directly from plants. Plants can literally release, even though this is not talked about too much, but plants can release carbon dioxide, especially at night when they're not photosynthesizing with the sun. They can release that carbon dioxide. Also, as you would know, animals typically release a lot of carbon dioxide directly when they respire or when they're breathing. Another thing that can happen is a lot of these shells can start to also go back into the earth, especially in a form that we call limestone, and wondering, first of all, where this carbon originally came from. Well, deep in the layers of the earth, we might have other kinds of rocks with carbon in them, like limestone. And as this volcano erupts, it's going to possibly carry that carbon dioxide with it as the volcano erupts, and the gases that come out could be carbon dioxide. So the rock cycle is another way that this is going to be released back into the atmosphere. And then a final way, or a pretty major way, that we're being affected by these days is the fossil fuels. Now, if we take this fossil fuel and we put it into some kind of motorized vehicle, in this case a boat, the boat is going to burn that fossil fuel, and it is going to also release this carbon back into the atmosphere, often as carbon dioxide. In this segment, we're going to talk about the nitrogen cycle. Nitrogen is often referred to as N2 because the atoms of nitrogen like to travel, or they're basically attached together. We find most of our nitrogen in the atmosphere. In fact, the atmosphere is approximately 78% nitrogen. So if you took a deep breath in, 78% of what you breathe in is basically nitrogen. Now, nitrogen is by itself not very useful because it's inert. It doesn't react with anything. But there's a few processes on Earth that can actually go and help us do something that we call fix nitrogen. Specifically, it's called nitrogen fixation. So what I'm going to show you first here is one of the processes that can actually fix nitrogen is in lightning. It can take nitrogen and it can combine it with some other elements and turn it into something like ammonia, so NH4. Another thing that can actually fix nitrogen is a class of plants, and these plants are pretty familiar to most of you actually. They're in the legume family, and they are what we might call a bean plant, but it's not the plant itself. It's actually down in the roots here. There are these nodules on the roots, and on the nodules live tiny little bacteria. So if you were to zoom in on there, you might see those little bacteria on the nodule of that plant. And what happens on that nodule is the bacteria are able to take nitrogen that is in the soil, and just like the lightning, it's able to fix it and turn it into something a bit more useful, like some form of ammonia. We have other types of bacteria all around in the soil here. So these bacteria could also take the ammonia and they could turn it into another useful form of nitrogen, which is a nitrate, so NO3. So either of these types of things, the ammonia or possibly even the nitrates, they could, through roots of other plants, they could go into those plants and help to grow big, healthy plants up here. Now, once we have other plants here, we could possibly have some animal come along, and that animal is going to eat those plants. The nitrogen is going to also come out as a waste product, and that waste is going to have a lot of ammonia in it, and that ammonia either can become useful again by plants, or again bacteria can take the ammonia and turn it back into a nitrate. Now within the soil though, there are other bacteria, and other bacteria that can actually take things like ammonia or nitrates, and they could denitrify it. So if we have denitrification, it's going to take things like ammonia and it's going to turn it back into regular nitrogen. We also have, I'm going to draw a little line here, we also have a concern over man-made nitrogen. So what's typically going on is a lot of times now humans have realized that in a factory we can take nitrogen and we can turn it into something like fertilizer. That nitrogen is then readily used by plants, and again you can see how this would get back into this process over here. If we have cars, and out of the tailpipes of the cars we often have combustion. If it's at a high enough temperature, you can possibly get a product of nitrous oxides, which we'll talk about later when we talk about pollution, but that can also factor into nitrogen being added into the atmosphere or into the environment. This video segment is going to talk about the phosphorus cycle. Now, much like the other two cycles, a lot of it has to do with the lithosphere. And we're starting in a slightly different place here. And the lithosphere is mainly what we would consider soil and rocks, the things that are underneath your feet. Now, in the lithosphere, we find phosphorus in the form of what we call phosphate. Okay, this is phosphate. So much like before, if you have some plants growing here, the roots from these plants can absorb the phosphates. So some kind of animal comes along, ingests those plants, those phosphates can pretty much go into the animal and be used for different things, but then they're going to come back out as some kind of waste product. And unlike carbon and nitrogen, the waste products are going to go back into the soil, and this process is going to be pretty much repeated within this smaller loop or this smaller cycle. One of the problems, though, is that phosphorus is considered pretty much a limiting factor. If you don't have phosphorus available, it's not allowed to combine within these living organisms like plants and animals like it normally would. And one of the major issues is that if you take a place that has lots of big trees, and those trees are holding lots of phosphates themselves, or lots of phosphorus, if you take and cut down those trees, you're possibly going to remove your source of phosphorus, and you're going to disrupt this cycle here. So instead of the phosphorus getting back into the soil, you might take that phosphorus and it could possibly get blown away through erosion, or it could get washed away or leached out of the soil. And we're going to discuss both of these a little bit more when we talk about soils. But if you don't have phosphorus in the soil, then you're not going to have a very productive area, and life and plants especially aren't really going to exist there. So with the absence of phosphorus, you would essentially have the absence of plants, and without plants, you're going to have the absence of a lot of animals, so you're going to disrupt this food chain. So the phosphorus cycle, you can see, is pretty small but very much dependent on the ability or the availability of phosphorus.